Okay, so now we'll talk a little bit about the nth term of a geometric sequence. So for a geometric sequence, the quotient of consecutive terms is a constant. That constant is called the common ratio. So the common ratio will denote R, common ratio, and it's what you get if you take two consecutive terms and divide one by the other. So that's how we find a common ratio between terms. And whenever you take two consecutive terms and divide them in a geometric sequence, you always get the same number. So, the nth term of a geometric sequence with first term a1, so the first term is a1, and a common ratio of r is the general term an, or the nth term, is equal to a1, which is the first term, times r, which is the common ratio, to the variable n minus 1. So that's pretty much how you're going to go about finding the nth term. So here's an example where they're asking us to find the nth term. So it says find the nth term of this geometric sequence. And from what we just learned, the general term, or the nth term, is equal to the first term times the common ratio to the power of n minus 1. So we need to know what the first term is. And looking at this, a1 is just 3. So I know that a1 is 3. And I need to know also, to do this, I also need to know not just a1, but I also need to know the common ratio. N is going to be the variable, so I don't need to know what that equals because it's changing. But a1 and r are fixed for any specific geometric sequence. So I need to find the common ratio. So I find the ratio of 6 to 3 and the ratio of 12 to 6 and the ratio of 24 to 12 and the ratio of 48 to 24. And it turns out they're all equal. So there is a common ratio because those are all equal to 2. All those ratios are common and equal to the same number, or are equal to the same number. So the ratio is common to all consecutive pairs, and that ratio is 2. So I found my common ratio. Now that I know the first term and the common ratio, it's quite straightforward. The nth term, the general term, is equal to a1, which is 3, times r, which is 2, to the power of n minus 1. And there's the function that gives us the nth term. So now that I have a formula for the nth term, I can find any term. First, second, third, fourth, fifth, sixth, seventh, eighth, it doesn't matter. So here's another example here. The question is, what is the 15th term? The 15th term of this geometric sequence. So I know that the nth term we just found was an equals 3 times 2 to the n minus 1. But now they're asking me for the 15th term, which is just plugging into the function. Is 3 times 2 to the 15 minus 1. 3 times 2 to the 14th power. So you follow your order of operation, parentheses, exponents, multiplication, division, addition, subtraction. You do the exponents first. And at the end, well, this is 3 times 16,384, which the final answer then is 49,152. So the 15th term in this geometric sequence is 49,152.